Hi guys, welcome to another episode of MrLopezClasses.com. This is our chapter 12 episode number 2 related with materials of fuel tanks. We are going to talk about the materials of the fuel tanks, the fittings, the connections, and at the end of the video we are going to talk about the fuel lines, how the fuel line should be installed properly in a typical engine room of a medium or big boat for diesel engines. Okay, I hope you enjoy the video. And now we are going to talk about the materials for the fuel tank. Remember, we are going to use stainless steel series 300 or aluminum series 5000. And I don't recommend galvanized steel. I don't recommend thermoplate steel. I recommend only stainless steel series 300 marine grade or aluminum series 5000 marine grade. Yes, the enemy of the fuel tanks is the accumulation, the concentration of water on top of the tank, because that concentration of water produces this erosion, especially in the corners of the tank. This is a special situation in aluminum tanks. The name of that type of corrosion is poultice corrosion. We are going to study in our book of corrosion that corrosion. What is the meaning of that corrosion? For now, you need to avoid the accumulation of water, stagnant water on the surface, on the top of the tank, in order to avoid this type of corrosion, poultice corrosion. Normally is an erosion produced especially in the corners. You can touch the metal and the metal is eroded like sand because of the accumulation of water. The name of that corrosion is poultice corrosion. Of course, all of those tanks should be fabricated in materials aluminum grade or stainless steel grade, and should be fabricated for welders certified. Never try to use other type of fuel tank. Oh, I have a good fuel tank, use it in my truck, I am going to use in my boat. No, probably the material is not appropriate, and the internal reinforces in the designs are not appropriate for marine application. Be careful with that. We are going to use only marine approved welders, only marine approved fabricators, and only marine approved materials. Other important thing is you need access in the deck of the boat easy where the fittings and the hoses and the valves are located. Boat builder must pressure test tank along with the system full of fuel. Steel tanks must never be encapsulated in foam and fiberglass. Oh yeah. Right now we are going to talk about that. The fuel tank should be located in a free area. No surrounded by carpet, no surrounded by foam, no surrounded by rubber. Should be free, and if the tank is over areas of fiberglass, should be separated a 1/4 inch in order to avoid in order to help that the water flow in between the tank and the fiberglass, and the water never be accumulated in between both of them. This is very important right now. I'm going to show to use a couple of examples. Okay, in terms of gasoline, the gasoline tank never be integral with the system. The same like in diesel. What is the meaning of that? Some years ago, the boat builders, they fabricate the boats with the fuel tank integral with the hull. In other words, the fuel tank is part of the hull. In between a couple of ball heads and the bilge, they close in fiberglass that area, and they dedicate that area for the fuel tank. This is not accepted in gasoline because the gasoline contains ethanol and methanol, and degrade the resin and produce gel, and the gel enter in the fuel system and clog the injectors and destroy the injection system, especially in gasoline. Okay, for that reason, in gasoline boats, never use integral tanks. In other words, the fuel tank should be separated from the structure of the boat. The tank should be fabricated in plastic or aluminum or stainless steel for gasoline, separated from the structure. In diesel, is accepted that the tank be part of the structure. Every day is less common. Every day the tanks are independent. In the new boats, they have independent tanks fabricated in stainless steel or aluminum. But you found that all boats, big boats, with diesel engines, and the tank integral with the system. I don't recommend because soon or later the resin in the fiberglass is degraded, and when the resin is degraded, produce gel, and the gel enter in the fuel system and clogged injectors and fuel injection pump. For that reason, I prefer use fuel tanks in aluminum or stainless steel. This is my recommendation. Okay, the ball head. This is the situation that the people use the ball head and the tank, and they use that area like the fuel tank. This is not recommended. If you have a crack in the structure of the boat, you have a leak of hundreds of gallons into the ocean. This is not good. And also, if you have a small porous in the structure of the boat, you have salt water entering into the fuel, and this is not good for the fuel system. I don't recommend under any circumstance that situation. Okay, the label. All the tank should have this label. This label is mandatory. This is the label. In the label is the city, the state, the zip code of the manufacturer, the date, the pressure, the material, the capacity, the year, the model. This is mandatory, this label in all the fuel tanks. And also this hole, in order to access the valves to close, the valves to bypass the fuel, should be located on top of the tank and easily access for those hoses, those fittings, those handles, those valves. Okay, the material, the metallic tank must be resistant to diesel and other typical liquid like lube, oil, grease, solvents, and salt water. If the tank is galvanized, the galvanized should be only in the external side. Now, I don't recommend galvanized steel. Galvanized steel, remember, is a regular plain steel covered with a zinc, pulverized zinc. This is not good. This is not good because what happened with the zinc? The zinc attracts the oxygen, and that's not good. I don't recommend under any circumstance tanks fabricated in galvanized steel. Never. Use only stainless steel marine grade. Alright, the next one, those are the series approved for the fabrication of fuel tanks. In aluminum, those are the series 5000, 5000, or this one 6000, and stainless steel series 300. Those are the series approved for the fabrication of fuel tanks. Remember, series 5000 and for aluminum, and series 300 for stainless steel marine grade. Okay, what is the meaning of thin plate steel? Thin plate steel is an steel, regular steel, covered with lead and tin. This is not good. This is not good. Over the time, the coating will form a thick paste that will clog the diesel fuel. That's not good. I don't like that. Use only stainless steel series 300 marine approved. It's a little more expensive, but you don't have any problems in the future. If you try to rebuild your boat, if you try to repower a boat, removing the gasoline engines and converting into diesel, one of the most important parts is install good fuel tanks. The original boat have plastic tanks. Yeah, we are going to eliminate those plastic tanks, and we are going to install new fuel tanks in aluminum or stainless steel marine grade, fabricated for a professional welder dedicated to the marine industry, and with the internal reinforcements, and we are going to install the brackets and the supports necessary to keep the tank separated from the surface, properly ventilated, with good access for the fittings and the hoses, and with a good access for the sensor of the level, with additional sensor with a clear pipe in order to verify the level of the fluid. Two possibilities to check the level: with the external side glass, or with the internal electrical or electronic sensor. Yeah, this is the procedure, and we are going to talk about that situation to convert the boat from gasoline to diesel later in other episode. Okay, my friends, and look at this, very important: never use self-wicking material or carpet in between the tank and the fiberglass. The tank should be installed separated from the surface a quarter inch, ABYC question, quarter inch, and must not be reached by normal accumulation of bilge water. Of course, avoid the accumulation of stagnant water on the surface of the tank in order to avoid poultice corrosion. The metallic tank. The metals should be, once again, appropriated metals, appropriated alloys, and be careful with the fittings. Be careful with the fittings. The fittings for those tanks should be I recommend in the same material of the tank. What is the meaning of that? If I have a stainless steel tank, series 300, I recommend all the fittings, if it's possible, in stainless steel or copper. In that case, no problem. If you have an aluminum tank, the fittings should be in aluminum. Be careful. Never install copper fittings in an aluminum tank. Copper and aluminums are enemies because accelerate the galvanic corrosion. Yeah, in the course of corrosion I am going to explain why that situation. But the copper and aluminums are no good friends. Be careful with the fittings. For example, in this slide, what is the inconvenient? What is the inconvenient of this picture? Everything is okay. Fitting, aluminum fitting, aluminum fitting, aluminum fitting, aluminum fitting, copper fitting, and copper cap here. This is not good. Yeah? The more noble metal attack the less noble, and soon or later you have a leak over there. What happened in the second picture? What is wrong? What is wrong? You have carpet. You have carpet here in between the fiberglass and the aluminum tank. And you have a bracket in steel. This is a steel and produce corrosion. This is a steel, bad quality. It's not a stainless steel. It's regular steel. You have two wrong scenarios. You have the tank directly over the surface with a carpet in between. The carpet absorbs humidity, accumulate moisture, and destroy the aluminum, accelerate the poultice corrosion in the surface of the tank. And additionally, you have a regular plain steel, the bracket here, and the steel with the contact with the salt water produce excessive corrosion, and the corrosion attack the aluminum tank and attack the fiberglass. Yes, my friends, the fiberglass can be corroded. What is the color of the fiberglass when the fiberglass is corroded? Yeah, it's yellow one. And what is the symptom when the fiberglass is corroded? You can delaminate the fiberglass with your hands. Yeah, the fiberglass can be corroded, especially if it's in contact with iron, with regular steel. Okay, my friends, let me check. Yeah, all the fasteners in aluminum tanks should be series 300 stainless steel. Yeah, the brackets, the straps, the supports should be in stainless steel or aluminum. Yeah, all metal parts of a tank should self-drain water. Yeah, from the surface. That's very, very, very important. Okay, my friend, the baffles. What is the function of the baffles internally and on the fuel tanks? Avoid excessive lateral forces on the boat. In order to keep the boat stable, those baffles with holes, keep the fluid in laminar movement, not turbulent movement. If the fluid is moving in the laminar flow, the lateral forces produced are smaller, and is easy drive the boat. Okay, the baffles must not trap the fluid on bottom or vapor at top. Yeah, that's very important. Free communication in the bottom and on top. The corners here, all the corners here in the welding areas are open. In other words, in the bottom, the fluid pass easily from one part to another one. Okay, and keep the movement of the fluid laminar, not turbulent. This is very, very important. If baffles opening in baffles, maximum 30% of the tank cross section. Yeah, those holes, if you add it, should be around 30% of the total area. Okay, the plastic tanks, foam material is not recommended like a support for bonding. Yeah, if you check, this is a fuel tank fabricated in steel and surrounded around with foam. I don't recommend. No, because it's a marine foam. No, all the foam at the end of the day absorb a little amount of moisture. Avoid that the metallic tank be encapsulated. Or if the tank is plastic, it's possible, no problem. But if the tank is metallic, aluminum or stainless steel, the tank should be free on the sides and on the bottom. The tank should be free, not encapsulated. Be careful with that. Yeah. All the foam must never change the volume more than 5%. I prefer no use foam. Yeah, this is a typical installation. This is a typical installation with foam around, and this is the final result. If you have a tank in a ferrous alloy surrounded by foam, at the end of the day, in 4 or 5 years, you remove the deck and you found that the tank fully corroded, and you have water on the fuel. You have the fuel mixed with water. That's catastrophic. This is not good. I don't recommend. Foam cannot be sole support from non-ferrous metal tanks. A non-ferrous metal tank foam in place, top must drain. Can be no gaps everywhere. Yeah, I don't recommend foam. I recommend the tank completely isolated. In a boat like this, I don't recommend a metallic tank or you can install the metallic tank if the tank will be completely isolated from the walls of the hull in the structure of the boat. That's difficult. In that case, I prefer a plastic tank. All right, I want to share to you this wonderful design for a fuel tank. This is a professional installation of a fuel tank, and yes, my friend, this is the boat. It's a fish boat. Look at the straps to keep the fuel tank. Look at the suction of the fuel. Look at the cap, completely sealed. This is the fuel tank for that boat. Catastrophic, my friends. Follow the ABYC recommendations for the materials, for the installation, for the brackets. We are going to review quickly the situation. Okay, the tank should be fabricated in aluminum, series 5000, or a couple of series 6000, or in stainless steel, series 300. The brackets should be in the same material. If the tank is in stainless steel, the bracket should be in stainless steel, and the fittings in stainless steel or copper for a stainless steel tank. For aluminum tank, you can use fittings in stainless steel, series 300, or fittings in aluminum, and all the brackets and supports in stainless steel, series 300 or aluminum if it's necessary. Never use copper in combination with aluminum, never, under any circumstance. The tank should be installed separated from the structure minimum a quarter inch in order to allow the flow of water. This is very important. And all the tanks should be located, the fittings, the valves on top of the tank. Remember in the tank you have supply lines, return lines, and you have vents. And the vent should be located on top, and the vent should be installed with the anti-siphon, and the vent should be located in a surface where the water pass and never penetrate. The fill socket should be located in an inclined area to avoid that the water penetrate the boat or penetrate into the socket and enter in the tank. And the tank should be fabricated for a professional company dedicated to fabricate marine tanks with appropriate materials and appropriate baffles internally in the tank. The hoses should be type A1 or A2. I recommend A1. This is the aspirin for the hoses. The clamp should be double hose clamps, cross clamps, and never together, separated a quarter inch. Very important. And the label should be located in an accessible area, in the same hole where you have access to the valves and the fitting. You can check the label. Those are the most important recommendations in relation with the installation of the fuel lines and the tanks. Okay guys, we are going to continue with the fuel lines. What is the recommendation for the fuel lines in inboard engines, diesel engines? My recommendation is try to organize the fuel lines professional. The fuel lines, the installation should be properly supported. The fuel line should be, in my opinion, rigid on the walls of the engine room, like the picture that you have on the screen right now. Those lines should be rigid, normally in copper or stainless steel. In some boats they use aluminum. All of those are metals used appropriated. I recommend use appropriated fittings in order to connect those lines. Right now I am going to explain the procedure. And the last portion of the connection, the last 2 feet, 3 feet maximum, should be flexible. In hose type A1, normally the fuel hoses type A1 are a blue color, like the hose that you have on the screen right now, with the properly labeled, indicating that is type A1 marine grade. And this is the last portion in order to enter into the fuel, into the priming pump of the fuel injection pump. Okay, the last portion flexible, and the rest of the line should be rigid, copper pipes, or stainless steel or aluminum, with the proper elbows, teeth, and fittings according with the diameter of the pipes. Yes, I recommend that you try to use good pipes, good connectors, the connectors appropriated, and don't forget the flare type of connectors are the most common in different dimensions: 3/8, 5/16, quarter, half, depending of the connection into the fuel injection pump, and depend of the fittings in the output of the fuel tank. Should be the diameter of the pipes. Look, those are the elbows, those are the typical valves. I recommend those type of pipes and those type of connectors, the flare types. You need to be familiarized with the installation of those types of connectors. Yeah, the flare connectors, you need to use the tool, and you need to be familiarized also with the pipe bending. This tool is necessary, is recommended in order to bend the pipes appropriated, in order to connect the pipes and organize the panels inside of the engine room. I recommend that you practice with the flare tool and with the bend pipe tool, different sizes of pipes. Remember that if the tank is in aluminum, we are going to use aluminum fittings like this, or stainless steel fittings like this, but never use copper fittings in aluminum tanks. If the tank is in stainless steel, you can use stainless steel fittings. If the tank is in aluminum, you can use aluminum fittings or stainless steel. In the stainless steel tank, you can also use copper fittings. Those connectors are excellent for fuel systems, because those connectors are hollow connectors. The fuel enter over there and the fuel continue here and enter normally at the input of the fuel injection pump. Be careful when you use this type of connectors, because you have two O-rings in copper, one O-ring over there and other O-ring in the bottom in copper. Those O-rings, like the O-ring that you have on the screen right now, are very important. If you lose one of those O-rings, after that, when you tie the knot, you never pressurize the system and the engine never starts. This is very important when you replace fuel filters. You need to be careful with those O-rings. You need to remove the fitting and keep the O-rings in a special plastic container marked where are located those O-rings, those copper washers, in order to replace the filter and putting back those copper washers. Those copper washers are the washers that create the pressure in the system. Be careful with those copper washers. You can keep in your car, in your minivan, a kit with a different type of copper washers and plastic washers and rubber washers, because in some fuel fittings you have a copper washer in one side and rubber washer in the other side, like the picture that you have on the screen right now. Those are specific for fuel system and gas or diesel. Okay, you need to be familiarized with those type of fittings and with the torque appropriated in each terminal. The service manual is the perfect reference in order to avoid over torque those terminals and damage the washer, and you have a leak, 100% sure. For that reason, those terminals, especially at the input of the fuel injection pumps and at the input of the fuel filter, should be torque appropriated in order to avoid damage the fittings and create a leak, and the system is not pressurized. The fuel system, especially in the high pressure side, is critical in terms of pressure. If the pressure is below the pressure required, the injector never opens. And the valves should be organized properly, exactly like you have in the picture in this moment. Those lines should be organized with the valves, with the labels indicating starboard engine, port side, starboard side, generators. I recommend, this is very important, create a discharge manifold and return manifold per each engine in order to connect fittings from the discharge manifold, like the manifold that you have on the screen right now, and fittings from the discharge manifold. Okay, the discharge manifold supply fuel to the engine, and the return manifold return fuel into the tank. This is good. Is for organization is better. The engine room looks professional. The engine room looks organized, and the troubleshoot is easy, because you can identify where is that the system is clogged, or where is that the system have a problem, probably leaks of air in the system. Remember that the air and humidity are the enemies of the fuel system in diesel engines. Be careful with that. Yes, we are going to install organized the Raycor Parker filters. Those filters should be organized properly, and the line should be organized with the valves appropriated, each valve per each engine, per each generator, starboard side, port side, with the discharge manifold and the return manifold. I recommend always when you install diesel engines, install discharge manifold and return manifold per each engine and per each generator. Other important element that we are going to install is shut-off valves, electrical valves, 12 volts or 24 volts, and solenoid valves in order to control the flow of the fluid at the output of the fuel tank or at the input of the fuel injection pump. In both cases, we have a shut-off valves or solenoid valves. This one in particular is a shut-off valve in order to cut the fuel at the output of the fuel tank, like the picture that you have on the screen right now. That valve is activated from this emergency push button, momentary push button located in the console. That button is activated if you have an emergency flame. The captain immediately activates that button and this valve closes and no more fuel is going out from the fuel tank. This is a shut-off valve. Okay, we are going to refresh a little the explanation that I gave to you in previous episodes in my electrical book about the solenoid valves. The solenoids can be used in other type of application like this. This is a solenoid. When the solenoid is powered, positive and negative, immediately the plunger closes the valve. This is a solenoid valve to control the movement of the fluid. What type of fluid? Water, gasoline, diesel, gas, alcohol, any type of fluid. The fluid can be controlled. The fluid enter here and continue over there. You see the shape of that valve. Okay, when the plunger is off, the valve is open and the fluid pass. When you activate the coil, the window close and the fluid no pass. This is a typical solenoid valve or shut-off valve. Where you found this type of valve in a boat? The shut-off valve for fuels in the output of the fuel tanks, or the shut-off valve at the entrance of the fuel injection pump to avoid that the fuel enter in the fuel injection pump and the engine stop, or the idle the idle solenoid on the carburetors to control the idle and to control that the engine start and stop. There are other applications in hydraulic system. In air conditioning system, we use solenoid valves. In an air conditioning system, the solenoid valve used to reverse the cycle from heating to cooling or cooling to heating. It's a solenoid valve, three-way valves that control the flow of the refrigerant to the evaporator or to the compressor, heating or cooling. There are other applications that we are going to study in our class of auxiliary systems or hydraulic systems, and also in our class of air conditioning. We are going to study other type of solenoid. All right, this is the solenoid valve, and we are going to install a lot of solenoid valves, especially in the output of the fuel tank. This is the typical shut-off valve used in emergency. If you remember some years ago, in the boats, they don't use electrical solenoid valves. They use the mechanical with the cable and the handle. But those valves are not used today. Those valves were replaced for the new ones, for the electrical 12 volts or 24 with the push button on the console. It's common, it's easy to install, and is reliable and accurate. Okay, my friends, and now we are going to start with the theory related with the fuel filters.